Welcome to Tech Notice. So if you've been around on the channel, you might have heard or seen my NAS upgrade story, which has been a very long time, and we tried to make this Asustor NAS into a video editing SSD NAS, but actually there was some complications. But in this video today, we're going to be upgrading that even further and actually finally finishing the network upgrade just after we finish this sponsored segment.
Looking for a cheap way to license your Windows? Check out Hookiees through the links in the video description. Make sure to use the code TN20
to get 25% off. Use your preferred payment method including PayPal or bank card. Go to your orders and copy the key.
Paste the license to the activation settings and you're all done. This license is for Windows 10, but you can upgrade it to Windows 11 for free.
Or you can buy Windows 11 Pro key instead.
They also offer Microsoft Office 19 license. Use the same code TN20
to get 25% off.
Check out Hookiees.com in the video description below.
So before we go into actually building the NAS and putting hard drives and stuff in, I want to explain what is going on in my network system currently and how this upgrade is actually going to help me and why we're upgrading and what's going on basically. So this is the current setup. I've got the main editing PC over here, which got 2.5 gig and 10 gig LAN that's built into the motherboard. Then we've got a Wi-Fi router where the internet actually is going to come in, and gives internet either wired or wireless to all of the things. Then we've got the main previous NAS, which is the Asustor Lockerstore 4, and we've got expansion units that's connected to it, but it's connected to two 2.5 gigabit LAN ports in there. Then I've got another 1 gigabit NAS that's for separate different purposes, and it's actually offline right now because I don't necessarily need those files there, but just to save some on the electricity bill. Then I've got my secondary PC, so that's the PC that's down there that I'm using, and they're all connected together. And how they are connected together are through these switches in here. So I've got two 2.5 gigabit switches, and they are connected to each other with two cables, and in a moment you'll see why. And the reason for that is because I've also got the main PC connected through the switches through two of the cables, which will actually give me 5 gigabits speed in total, because the other NAS here from there is connected to there and to there. And because we've got basically this PC and the NAS connected to two 2.5 gigabit cables and, well, ports really, or connections is the right word to say. And when enabling SMT through the software on the NAS, I can actually get sequential speeds of up to 5 gigabits per second through that PC to that NAS. And now in the NAS, there is actually bottlenecks, which are the hard drives, because the hard drives only go to about, 300 megabytes per second max, but the 5 gigabit speed is actually higher than that, so the hard drives are the limiting factor in there. But you do have some NVMe SSDs in there as well, but I'm using these there as a caching of all of these there, so that's why this connection is kind of fully saturated 2.5 gigabit, because we're constantly using a lot of big files from this bit over here to the main PC, and then I'm editing sometimes thumbnails or something on the other PC that are on this NAS at the same time. So this other PC has a 2.5 gigabit port, and that's connected to there. And then we have the Wi-Fi, which is connected to there. And as you can see very quickly, all of these 2.5 gigabit ports have been, taken up, and everything is connected. Now the upgrade that we're going to be doing is adding this guy here, which is the Asustor Lockerstore 6 Gen 2. But this one has stock two 2.5 gigabit LAN ports like the first one, except there's a few more drives in there that you can put in there, plus 4 NVMe slots in there. But what we'll be doing is we're going to take the NVMe card out and put in this card here, which actually gives us a 10 gigabit port and 2 NVMe drive slots in there. Plus, we have a 10 gigabit switch. So this is from Trendnet, and this, at the time of me actually, acquiring this, was one of the more affordable ones and best ones that I could get, because, saving money is always good, right? I'm not sure of the pricing right now, but I'll leave everything that I'm talking about in the description below. So here's what's going to happen. So basically now we're going to be adding the 10 gigabit switch here, and now we have 8 ports there that are 10 gigabits In speed, that's 4, 5, 6, 7, 8. And then we have the new NAS here that has a 110 gig port there. And this one has 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And that's going to be connected to this 10 gigabit LAN now. And obviously now we're going to have one of these ports on the 2.5 gigabit now connected to the other switch, so everything can talk to each other. So instead of this 10 gig going there now, this 10 gig is gonna go in there, leaves one empty spot in there, which we're gonna be connecting into there. Now, we could connect 2 of these into this as well, and we could later on upgrade to a 10 gigabit SMT, which means that if I'm gonna put a network card in there and have 2 10 gig ports here, both of them, and then if I connect both of these to that network switch over here, I will get 20 gigabits theoretical, speed of the NAS or something. I've got something in the works. Asustor has the NVMe FLASHTORE as well, which we could really use as like an editing NAS on there, and that would be absolutely insane if we could do that. So this 10 gig here has a few empty slots and options, and now with this 2.5 gig we're still going to be connecting it to the first switches because there's no like connection that we need because this is only 2.5 gig. So now I can choose, so the devices that need only 2.5 gigabit or less bandwidth, we can connect to these like smaller switches, but then the fast NAS and editing PCs, we're just going to connect to the 10 gigabit switch, and then we can talk to the NAS really, really fast and get 10 gigabits per second maximum sequential, read and write speeds, which when we're hammering NAS, few devices or few PCs at the same time, then the 10 gig is really important. Plus, if you want to transfer files onto that one, it's important as well. Now let's start with this 10 gigabit card, because this is where things get very, very interesting. So we'll take the heatsink off. Screws are in very, very tight. And for the SSDs to use for there, I'm going to use the Solidigm P44 Pro, and these are the 2 terabyte drives. So altogether, we're going to have 4 terabytes. I'm going to run them at RAID 0, which means that I'm going to get double the read performance, but half the write performance. I'll explain this now for you if you don't know what RAIDs and these means. Installation, by the way, is very simple. You plug it in there and then pop it down, and there's like a toolless clip there that will just do that. Plus, these Solidigm P44 Pro drives only have the chips on top side of it. There's nothing underneath, so I don't have to worry about cooling the underneath there, because the top is which gets the heatsink on, like that. We're gonna pull these off. Just slot that on the top there. Put these 2 screws back. I want to explain how this storage works on that as RAID 0. So basically what we will have is the 2 NVMe SSDs here, right? And all together what you will get is 4 terabytes because it's 2 plus 2. But the way how data is written on it, you're actually going to write some of the data on this one, on the first one. Let's say data A, right? There's some going to be here and some here, and then data B, like something else, will be here. So the same data is going to be split between them. You still get the same maximum capacity, but the one downside is that it's not going to have any redundancy. So if one of these drives fails, that's it, all of the drives are going to fail. And you're going to say, why would you want to do that? So here's the reason. I'm actually going to be creating these 2 drives in RAID 0, right? This will give me the best performance as random read and write speed. So all of the little files and random reads that I'm actually interested in, because if I've got loads of little assets, like lots of little pictures and lots of little files all over the place, and perhaps using this 4 terabyte as even a project drive, there's going to be a lot of random little files that's going to be created, temporary cache files, temporary things in there, but I want to read them as fast as possible. And the random read speeds of these Solidigm P44 Pros are like one of the best on the market. Like in my testing, even better than the Samsung 990 Pro at some point. Plus, their terabytes written spec is higher than Samsung's as well, which means that we can hammer it with a bit more larger files, which it can handle it a bit better. But I'm gonna create a redundancy backup of this whole 4 terabyte drive on a separate NAS or a PC or hard drive somewhere else, where this whole thing gets packed up somewhere else daily or a few times a day, which means that I don't need to worry about the redundancy of this because it's taken care of somewhere else. What I'll be storing in there are all of the B-roll that we're going to use in all of the different videos, plus the thumbnails and things like that. So that's how we're going to be using that. Now, I could use these 2 SSDs as caching as well for some of these drives in there, but because I'm not using websites or something that I'm running on this, the caching isn't really going to give me the best performance in terms of for my workflow. I want something like, you know, really fast and so on. Also, you might be asking, wait a second, these are actually Gen 3 slots here, but you've put Gen 4 drives in there. Yes, the sequential read and write speeds, I'm not gonna get the Gen 4 speeds, but remember, we're actually capped by this 10 gigabit port, so that doesn't matter anyway. So now let's get these SSDs off from here. Remember these Seagate ones, these aren't actually firmware compatible with this one because they're a little bit older drives and they just couldn't figure out the firmware with this that I mentioned in the previous video. So we're going to be putting hard drives back in there, which will be these Seagate Ironwolf NAS drives. So these aren't the Pro drives, so they actually have a little bit of a slower speed. But the main idea here is to get some more storage, not necessarily the speed of the storage in terms of the hard drive base, the 6 bays. So 6 times 4 plus running them in RAID 5, I'm gonna get 5 out of 6 drives capacity, which means that I will be getting 20 terabytes of extra storage, which I'll be very happy about. Now, before I'm gonna put the hard drives in, because that's gonna make the NAS very, very heavy, I'm actually gonna undo this and we're gonna install the 10 gigabit port inside here. So you've got these 3 screws from the back, take them off. And now the cover just slides off just like that. And now, essentially with these 2 screws loose, this literally just pops off like that. And what we'll do is in the back here, we're going to take these screws off as well. So now the back cover comes off. And if we pop this back in, you can see there's a screw hole in there as well. So this goes in, boom, pops right back in. And then now using the same screw into there. And now we can put the cover back on the top. Okay, now let's take these SSDs off and then put the hard drives in there. So this NAS hardware is actually ready now, and I wish Asustor would do some kind of a quick release system for the hard drives, because screwing this takes a long time, especially if you need to maintenance. Let's say one drive goes, you want to quickly pop another one in. I wish there was a simpler way. But this Trendnet 10 gigabit switch is pretty simple actually. There's a one power, just usual kettle lead power cord in the back. So the power supply is actually inside, I think somewhere over there. And then we've got 8 ports in the front here, all of them 10 gigabit ports. And there's a fan on one of the sides here. That's on the right side if you look from the front. And then a grill on the other side where the airflow will come out. And in the box there is actually some clips. So if you want to put it in the rack, you can do that as well. It says here, rack mountable. So now let's install these where the other NAS and network items are. Okay, putting the switch there, plugging it in, I realized that the included fan on the switch is extremely loud. Can you hear this? It's so loud. And I'll unplug it here now. Okay, there is only actually 2 connectors there, which basically means it's just live and neutral basically that goes into this, because this is a DC fan. It just goes same speed all the time, kind of industrial thing. And if it's in a rack somewhere in another room, it's completely fine. But I'm actually going to change it out to this Noctua NFA4 X20 fan, which is the same size, but it is much quieter. So listen to the difference of this. The Noctua fan is right now 100% speed. You can't hear it. And that's the main reason we need to change it, because I can't have this fan there because the switch is going to be in the same room where we're filming. So here's the difference of these fans. You can see that the Noctua fan has more blades than the industrial one. And the industrial one is 0.2 amperes and the Noctua one is 0.05 amperes, which means that the industrial one is actually 4 times more powerful. But the quietness is what I'm after more, because I think it's going to be completely fine. Noctua brown on the side, that's what we like to see. Let's plug this in again. Even though this is a PWM connector, the last 2 connectors will just supply power to the fan, and that is enough what we need. But just the inside is quite simple. You've got a little motherboard with some heat sinks on. Here's like the, switch controllers or whatever. Little power supply. Power goes onto the motherboard, switches on the side, plugs on the side here, and that's it. And that was very simple. Highly recommend doing the fan exchange when you are getting this switch, if you have the switch in your room. So, it's been a very long time. As you can see, we are many months later, but I finally have Asustor Lockerstore 6 Gen 2 NAS working, and I've got the performance that I want. I had some issues with performance, and whenever you have an issue in a PC world, most of the time what has happened is that the issue or the problem is much more simpler than you think. You start to think, oh no, something very complicated is going on, but the issue is something very simple, and I'll show you what my issue was. In the earlier part of the video, you remember that we used these Solidigm P44 Pro 2TB drives. These are amazing Gen 4 drives and amazing speed, really generally one of the best Gen 4 drives you can get. And if you look at Asustor's actual compatibility list of what we can get there, then as you can see, there is 2TB version of Solidigm, but it is P41 Plus. The P44 Pro is only a 1TB one here. So even though you see it kind of in the compatibility list, you'd think, well, yeah, if 512 gigabytes works, 1TB works, 2TB surely works as well. But that's where the problem was. The 2TB version didn't quite work. Well, actually it did work, but it only got about 500 megabytes read and write speeds generally there. This is nowhere near enough what it should be. And I gave a right headache to Marco from Asustor trying to figure out what was going on. He does the same thing, puts different NVMEs in there and gets a similar results, but there was a different, operating systems, different systems. We thought that maybe the NIC is not working because we couldn't see any bottlenecks in any of the hardware and what was going on. And then we thought, well, let's just try different SSDs. And then we tried the Team Group T-Create Classic SSDs. And these are one of the lower end Gen 3 SSDs that you can get there. Very affordable, a lot more cheaper than the P44 Pro in some of the instances. I'll leave both of these linked in the description below. So we took 2 of these, put them in there, and then did the test, and we're getting pretty much double the speed what we're getting with the Solidigm P44 Pro. And we're saying this doesn't make any sense. But here's how important it is to have a validated NVMe SSD that you can see on there, especially when you're working with NAS drives, because there might be some kind of whatever random error or something going on somewhere that isn't exactly the same. Even though the 1 terabyte version was validated, you can see that in the list there, the 2 terabyte version wasn't, and as you can see, we're not getting the full speed of it. So sometimes when you want to spend more, you actually might not get a better performance, and it's worth going much lower that is validated and simple and just works, as you can see in this instance. And I'm going to show you the test results now, but I wanted to show you this first. So we are on this PC. You might have seen the build of this one. We're using the Gigabyte Z690 Aero D board, which we've got a 10 gigabit Ethernet in the back there. So that Ethernet is connected to the 10 gigabit switch that you saw me set up earlier. And then from the switch, there's another cable that comes in the back of this here. And I haven't put the cover in yet because I was testing these M.2s, and when I found out that these work, I wanted to make the video instantly. Firstly, I need to show you how this is set up. I've got the storage here on this Asustor Lockerstore 6 Gen 2, and you can see that I've got the 6 bays all here installed, and these are the hard drives that we installed earlier. And I've actually completely filled the 18 terabytes by the earlier time of this video because I thought I need some storage. So actually it's completely full. As you can see, there's only 687 gigabytes left, which will be like maybe 2 videos, maybe 1 video, and then this is like 100% full as well. So all the hard drives are basically just archive footage in there, but then the M.2 SSDs on the top there are volume 2, and as you can see, I'm running the volume 2 in RAID 0, which means that we should be getting even more performance than what we're getting with just no RAIDs from there. But RAID 0 will give us better read performance when we're doing random read and writes, because the data is split between 2 drives, if that makes sense. So RAID 0 will give us a bit of a better performance, but I just want to show you the performance right now. I've got that test SSD, so that is on that NVMe SSD drive. And then if we take another folder here, for example, desktop, and we're running the 99 Evo from Samsung on the desktop. So we're going to take this copy file here, take it from the NAS through the switch to the desktop, and let's take a look at the read speed. We're reading files 1.1 gigabytes per second, not gigabits, gigabytes per second, right? That is super, super fast. So as you can see, 163 gigabyte files, 173 gigabytes files, we're copying about 2 minutes, 30 seconds, maybe even less. That shows you the speed of the 10 gigabit Ethernet. As you can see, the 10 gigabit Ethernet is the theoretical maximum is 1250 megabytes per second, I believe. So here we have a little bit less, but this is still very, very close to the theoretical maximum bandwidth there. So reading files from it, that's absolutely amazing. So now let's write something on these NVMe drives in there. So I'm going to take this file from the desktop, this 35 gigabytes, and we're going to copy it onto the NAS. And you can see, look at that, 930 gigabytes per second, sorry, megabytes per second. And it's slowly gonna stay there and slowly gonna go down and then roughly stay around 700 to 800 or 700 to 900 megabytes per second. Now, why is the speed going down? Because that is actually very CPU intensive workload and single threaded. So now the CPU that's inside this NAS, once the boost clock actually, goes down, it will drop in speed. So this 37 gigabytes file pretty much didn't drop the speed at all. So we're copying about 900 megabytes per second, which is absolutely amazing. So if we are writing something on it, let's say you take your footage and you're ingesting on it, you can get very, very fast speeds. Let's say that we don't have RAID on the volume. So if we go to Storage Manager, we're going to take the volume 2 and we're going to remove. On volume 2, everything will go, okay? So we're just deleting volume 2. It's completely going to be going. And now we're going to create a new volume. Advanced setup. Next. So now JBOD, there is no RAID. They're just all kind of there all together, like pooled together. So there's no redundancy, no RAID going on. So we don't get any advantage of any extra speed or any lower speeds. Volume 2 there. Now it's building system file there. It's going to do that quite fast. What I want to show you also a difference is between the 10 gigabit and 2.5 gigabit NAS. If we are taking this one here, so this is our other NAS, the 4-bay one that only supports 2.5 gigabit Ethernet. And if I take anything from there, let's take this file there from that NAS, and then we're going to put this on this desktop here. If I'm gonna paste it, you can see we're only copying roughly around 250 megabytes per second from that. And even though 2.5 gigabit Ethernet kind of theoretical bandwidth can go a little bit higher, that's how much we're really gonna get. We're not gonna get any more than that. And if, let's say, we're copying a file onto that NAS as well, 200, see, we're getting about 4 or 5 times faster speeds on the 10 gigabit Ethernet or 10 gigabit NAS here with those NVMe's. Obviously, the drive performance matters as well. We're not going to be writing like 10 gigabits or like 800 megabytes per second on these hard drives. That's not possible, but that's the hybrid benefit of having some fast drives in there if you just want to use something that's fast in there. Yep, it's all built now. Now there's no RAID on it. Let's see if we're writing anything any differently. And as you can see, we're writing on it still the same 900, 800 megabytes per second. Between 800 and 900, sometimes drops down a little bit. So as you can see now with JBOD, our write speeds are not as stable. It kind of goes up and down, up and down, up and down. There's a bigger wave than in RAID 0, but still between 700 and 800 megabytes per second, or 700 and 900 megabytes per second. That's pretty cool. Now let's try copying that file back from the NAS to here. Now here you see the benefit of RAID 0 in read performance. So let's say we had some kind of files in there, that our project files or some assets. You can see that when we're just piling them to pooling them together into one, we're only seeing 770 or 780 megabytes per second read speed, which are not particularly fast. We were extra 200 megabytes faster in RAID 0 because we were RAID 0 and we were able to like read files from both drives at the same time. So then, am I happy about the performance of this NAS? I think it's absolutely amazing to have a hybrid option here where we can put some fast assets onto the NVMe SSDs. We can get 10 gigabit Ethernet, and finally we got much faster connection than 2.5 gigabit speed, especially if you're working with large files as a creator. When you have video and photo or other files, you can read much faster of them. So I've got 2 of these T-Create Classics in there. In fact, I have 6 altogether, and there's something coming out, and I want to say thanks for Team Group for sending these, because we've got another project coming out. There is something from Asus called the FLASHTORE NAS, all NVMe NAS, and I'm super excited about that one because that might take it to a whole new another level. So we'll have to subscribe if you want to see that. Well, the NAS works, it's all good now. It's time to start using it. Thanks guys for watching. Bye bye.